Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today's discussion will be about the isometric projections of a hexagonal prism and the three orientations of this hexagonal prism we are going to discuss today. Now the first one is when the isometric projections of the hexagonal prism are to be drawn when it is resting on its hexagonal base on the horizontal plane and its axis will be perpendicular to the horizontal plane. So in the first case we are going to have two sub cases over there. In the first sub case, when the axis is perpendicular to the HP and the prism is resting on its base in the horizontal plane, we are going to assume that the two base edges of this prism, they will be perpendicular to the vertical plane. And in the second sub case, we are going to pick up that the two base edges, they will be parallel to the vertical plane. So this way, two different orientations of the hexagonal prism which is standing upright on its base on the horizontal plane will be discussed. Then the second one is we will be drawing the isometric projections of a hexagonal prism which is resting on its rectangular face onto the ground and its axis will be parallel to the horizontal plane. So let us pick up case number 1 in which the hexagonal prism is having the base side 30 millimeter, axis height is given to us as 60 millimeter. It is resting on its base on the horizontal plane with its axis perpendicular to the HP, and there are two base edges which happen to be perpendicular to the vertical plane. So this is an additional information we have got. So to begin with, we have to start with the geometric construction of the hexagon with base edge is equal to 30 millimeter. So this is the 30 millimeter base edge. So this base edge we are going to draw here, and all the edges 2, 3, 1, 2, 3, 4, 4, 5, 5, 6 and 6, 1, they will all be equal to 30 millimeter, and the external angle of this hexagon we are going to draw as 60 degree over there. Now in this case we have worked out that we cannot draw this hexagon straight away onto the isometric projection. The reason is that because only two of the edges, that is 1, 2 and 4, 5. So these are the only two edges of this hexagonal prism which are going to lie on the isometric axis or on the isometric lines. Whereas the another four edges, that is 2, 3, 3, 4, 5, 6 and 6, 1. So these edges, they are non-isometric edges, and in the case of isometric projections we also know that neither the angles they are preserved nor the shape will be preserved over there. So what we have to do in order to draw this hexagonal shape onto the isometric projections, we have to inscribe this geometric construction of the hexagon which we have already drawn to true scale into a rectangular shape. So this is a rectangular figure ABCD. So this rectangular figure we have drawn to inscribe this particular hexagonal figure over there. Now this rectangular shape will be first of all drawn onto the isometric projections using the isometric distances over there. So first thing we need to do is we have to draw the isometric scale, and all the dimensions of this particular construction, they will be transferred onto the true scale and then they will be converted into the isometric distances over there, and only the isometric distances, they will be drawn onto the isometric projections, right? Now another thing is there that in this rectangle we have obtained that there is a longer edge which is AB and there is a shorter edge which happens to be BC, and this longer edge AB we have marked as X millimeter and this shorter edge BC, we have marked it equal to distance y, which is y millimeter. Now we know the distance x, we know the distance y. So in the true length, both of these distances, they are available with us. So we'll be converting them to the isometric lengths over there corresponding to x and y, and those lengths will be plotted onto the isometric projection. And one more thing we have carried out in this construction, that once you complete this geometric hexagonal construction over there, so we are going to join the diagonals 1, 4, 2, 5 and 3, 6, and wherever these three diagonals they are going to join, we get the center point of this particular hexagonal base over there. Now we have obtained this center point, but then since the distances and the angles, they will not be preserved in the isometric projections, so we need to work out the rectilinear location of this axis point O over there. So this rectilinear distance will be marked as, you see, A to E. So we are going to measure the distance of A to E point, and then a vertical center line will be drawn. Similarly, we will be measuring the distance of B to F over there. So this is B to F distance, and then again a central line which will be parallel to AB will be drawn over there. So wherever these two axis line or the center lines they will be joining, so we are going to get the location of the axis point O. So A to E will give us the vertical center line, and B to F distance will give us the location of the horizontal central line over there. So this way the axis point can also be located in the isometric projections. So let us start with the isometric projections of the hexagonal prism. So one thing we need to understand, that this is our horizontal ground line or the datum line. So we have marked a point, starting point onto the datum line, and on the left side the x-axis will be drawn at an angle of 30 degree. Towards the right, the y-axis will be drawn at an angle of 30 degree, and the height of the prism will be marked along the y-axis, and this height is given to us as 60 millimeter. Now we know that this hexagonal prism is resting on its base lying in the horizontal plane. So this hexagon shape is to be drawn onto the horizontal plane. So on the horizontal plane means that whatever rectangle we have drawn which is inscribing this particular hexagonal shape, so this rectangular figure A, B, C, D, it will be drawn along the x-axis and the z-axis over there. That is, in the xz plane I am going to locate the base of this particular hexagonal prism. Now this is the rectangle. Now I need to work out whether I should be locating my x dimension over here, or I should be locating my x dimension in this orientation, that is along the x-axis. Now if I locate my x dimension, that is distance of A to B along z-axis, please see what's going to happen. If I locate the distance AB along the z-axis, what I will be getting? I will be getting the location of points 1 and 2 onto this isometric axis over there. Similarly, other 2 points will be lying, that is 4 and 5, will be lying on the isometric edge over here onto this place. So this way the two edges of the hexagon, they will become perpendicular to the vertical plane. So this we consider as a vertical plane. So these two edges, they will become perpendicular to the vertical plane. So that is why you see we have chosen to locate the longer edge of the rectangle along the z-axis and shorter edge of the rectangle, that is AD, along the y-axis. So this is our AD distance over here. This is A, this is the distance D over here. So AD has been located along the x-axis and AB has been located along the z-axis, so that 1 and 2 points will be located here and 4 and 5 points of this hexagonal base will be located along this particular direction. So this will give us perpendicular orientation with respect to the vertical plane. Right now, having located and drawn this edge equal to x, Now two more isometric lines we have drawn. This line CD is parallel to AB and this line BC, it is parallel to AD. So by drawing these two isometric lines, we have been able to complete this base of this hexagon, right? So within this rectangular base, we are going to locate all the 6 corners or the 6 points of the hexagon over there. So the bottom has been drawn, that is the bottom face of the hexagonal prism has been drawn, which is a rectangle over here right now. Now let me draw the vertical axis. That is vertical axis. I know the height of this prism. Length of the axis is equal to 60 millimeter. Now from on the y-axis, please check. This is my y-axis. So on the y-axis, we are going to locate the height of this particular prism. Now corresponding to these points A, B, C and D. So 4 vertical edges we are required to draw. So please check. This vertical edge and this vertical edge, they both happen to be parallel to the y-axis, right? So now we are going to complete the top face because the bottom face has already been completed. So this is A, B, C, D. This is the bottom face of the hexagonal prism. Now let us complete the top face. So in the top face, once again, another rectangle of the same shape and size has to be drawn at the distance of height of 60 millimeter from the bottom over there. The length of all the vertical edges will be 60 millimeter in this particular case. Now we have drawn another isometric edge which is parallel to z-axis. Another isometric edge has been drawn which is parallel to the isometric x-axis over there. Now couple of more, you see, isometric lines we need to draw in order to complete the top face of this particular prism, right? So please check. Another edge we have drawn which is parallel to the z-axis, and this edge is parallel to this edge, it is parallel to this edge, and all these 3 edges, they are parallel to the z-axis. Similarly, this edge, this one, all these 3 edges, they are parallel to the x-axis, and the measurements of all these 3 edges, it is equal to y. Similarly, this vertical edge, this vertical edge, this vertical edge and this one, they are all parallel to each other and they are parallel to the y-axis over there, and the height of each of the vertical edges is 60 millimeter. So we have completed the construction of the top face of this prism and the bottom face of this prism, and this is nothing but this is a rectangular prism which we have been able to develop. So in this rectangular prism, this is the longer edge and this is the shorter edge. So there are 2 rectangular faces, one at the top and another one at the bottom. So on both of these rectangular faces, now we are going to locate all the 6 points of this hexagonal prism so that we can complete the construction of the hexagonal prism, and these 6 points, they will be located using the rectilinear distances only, right? Because angles and the shape, they are not going to be preserved in the isometric projection. So let us first of all find out the center point at the base. So in order to evaluate center point at the base, please check. This is the corner A. From the corner A, as we move towards point B, there is midpoint over there, that is point E. So we are going to measure this distance in the true length, convert it to the isometric length, and we are going to mark this distance from A to B. So we are going to move from A towards point B. So distance of AE will be marked over here. The moment we locate point E, now parallel to this x-axis, this center line will be drawn over there. Similarly, from point B, we are going to move towards point C, and we are going to measure the distance of B with F. So BF distance we are going to evaluate from the original figure, convert it into the true length points, and once we get the true length distance over here converted into the isometric length, so this true length distance will be converted to the isometric length over here, and from this point center line which will be parallel to the z axis will be drawn. So these two intersections of the center lines will give me the axis point corresponding to the base. Now corresponding to these 4 points A, B, C and D of the bottom, at the top points will be A1, B1, C1 and D1. So the vertical edges will be AA1, BB1, CC1 and DD1, right? Now we have got the top face. So similarly on the top face, the center point or the axis point will be located. So once again from A1, I will be measuring the distance of point E, and this distance will be plotted as E1. This is A1, this is E1. Once we measure this distance, so the first center line parallel to the x-axis will be drawn. Similarly from B1, we measure the distance up to F, B and F, and again the isometric distance will be marked over here, and from this point F1, another center line which will be parallel to the z-axis, this will be drawn. So we have obtained the axis point at the top, axis point at the bottom has also been located. Now we have to locate the 6 points of the hexagon in the bottom face as well as in the top face. So please check the distance of A1, B2, C4 and D5. They are all equal. So once we measure this distance A1, this will be equal to B2 and C4 and D5. So these are true length distances in the geometric construction. So once again they will be converted into the isometric length, and from A I have marked point 1. Similarly from A I have marked point 1 over here. Similarly from point B, second point has been marked. So points on the base, they will not be having any suffix, whereas points at the top surface, they will be called A1, 1, 1, 1. Okay. Similarly if this is B1, so name of this point will be 2, 1. Right. Similarly now we are going to mark point 3 at the bottom, and 3, 1 point will be marked at the top. So what is the distance of this particular point 3 and 3, 1? We measure the length B3 in the true length over here and then convert it to isometric length. So this distance will be marked over here. So on the base we are going to get point 3 from point B over here. Similarly at the top the same distance will be traveled over there along B1 C1. So the name of this point will be 3, 1. So this distance will be B1 3, 1. It is equal to B3. Right. Now next 2 points, that is 4 and 5. So we have already measured A1 and 2B. So similar distances are there for 4C and 5D. So from point D you go towards C and mark an arc over here. So this will give us 0.5. Similarly from point C, as we are moving towards point D, mark the same distance. So we get 0.4. Similarly points 4, 1 and 5, 1 have been obtained, and finally point 6 and 6, 1 will be located depending upon this distance. A6 will be the distance which I am going to mark over here. So now A6 distance I have marked onto this isometric projection. Similarly this distance will be A1, 6, 1. Now let me join all the edges of this hexagonal prism which are visible to the observer. So please check all the top surface points 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. They are all visible to the observer. Since the observer is going to look at this prism from this side, so all these edges of the top face, they are visible to the observer. So they have been drawn dark. Now the vertical edges, please check. What are the vertical edges which will be visible? They are 5, 1, 5, 6, 1, 6, then you have 1, 1, 1, then 2, 1, 2, right? And then the remaining edges 3, 1, 3, this is not visible to the observer. Similarly 4, 1, 4, it is also not visible to the observer. So these two vertical edges, they are not visible to the observer because they are going to lie on the back side. But over here you can check in the base. 5, 6 is visible, so we have drawn it dark. 6, 1 is visible, it's lying in the front side. 1, 2 is also visible, it's lying on the front side. But The edges 2, 3, 3, 4 and 4, 5, they are also not visible. So 3 edges of the base, they are not visible to the observer. So we have joined them using the construction line. So we cannot draw hidden lines over there or the dotted lines over there. So the 3 edges of the base and 2 vertical edges, they are not visible to the observer. So these will be drawn light using the construction line, so that we can have the real feel of the complete hexagonal prism, and we ensure that all the edges of the prism, they have been appropriately joined with each other. So even if we omit this construction 4, 5 or 3, 4 or 2, 3 or even 3, 1, 3 and 4, 1, 4. So even if we delete or omit these 5 edges, our construction would still be complete. But just for the purpose of showing the completeness of this hexagonal prism construction, so we have shown these 5 edges even if they are not visible using construction lines only. So no hidden lines are to be drawn. So this is the complete construction of a hexagonal prism, in which 2 of the base edges, they are perpendicular to the vertical plane. Now in the next case we will be discussing the projections of the hexagonal prism when these 2 edges, they will be parallel to the vertical plane. So this longer edge we will be drawing in this orientation, and the shorter edge we will be shifting it over here. And finally you can check in this figure also, the axis has been joined. O is the top point of the axis, O1 is the bottom point of the axis. Now let us start with the second construction. So all the procedure will remain same. First of all, the geometric construction of the hexagon will be prepared. Then this will be inscribed within a rectangular figure, and the midpoint, that is the axis point, will be obtained just like in the previous case, and the distance of axis will be A, E and BF once again. Now all these distances we are going to convert into isometric length distances, and then the construction of the projections will be starting. So as usual, we have constructed the ground or the horizontal figure datum line. We are going to mark a point over here, and then towards the x-axis the 30-degree angle will be drawn, and the z-axis will be drawn again at an angle of 30 degree with respect to this datum, and the height will be marked along the y-axis over there. Now in this figure, once again, the hexagon is resting on the base on the horizontal plane. So the base, that is the rectangle, will be shown along the x and z plane over there. So we have to work out whether towards x-axis we have to draw the x dimension, or towards the z-axis we need to draw the x dimension over there. So as we have discussed, when we are going to draw x dimension over here, so this is our vertical plane. So onto the vertical plane we will see that these 2 edges of the hexagon, they will be parallel to the vertical plane. So this is our vertical plane. So this edge 4, 5 and 2, 1, so they will be lying onto these 2 isometric axis line over here. So this way we have to draw the longer edge of the rectangle on this side, and the shorter edge will be drawn along this particular side over here. Now once we complete this base rectangle, please check, this is the longer edge which I have marked along the x-axis AB. Then BC, I have marked the shorter edge of this rectangle along the z-axis. Then these 2 edges, they are drawn like isometric lines. So AD is parallel to BC and it is equal to BC. CD is parallel to AB and the distance is equal to x over here. So the base of this particular prism has been completed. So this is my base. So through these isometric lines, I am going to measure the rectilinear distances and the location of all these points 1, 2, 3, 4, 5, 6 will be completed onto the base. But before I start with that, I have to draw the axis point. So please check, from point A, I measure the distance E. Please check, from A, I measure the distance E, and then this center line will be drawn. Similarly, from B, I measure this distance F, and again second center line will be drawn. So from B, I have measured the distance F as I move towards point C, and then another X center line parallel to the x-axis has been drawn. So wherever these two center lines they meet each other, I am going to get the location of the point O1 onto the base, right? So here the base of this particular hexagonal prism, the guideline has been developed. Now let me draw the vertical dimension over here. The axis length is given to me as 60 millimeter. So this is 60 millimeter axis length. This is y axis. So I have drawn this axis length along the y axis. Now from the points C, D and A, another three isometric lines which are vertical and parallel to the y axis, they will also be drawn so that I can obtain the top face. So just check 1, 2 and 3. So these isometric lines they have been drawn and equal to this y axis. Now I am going to complete the top face. So again 4 isometric lines I will be requiring, 1, 2, 3 and 4. So this way the top face of this particular hexagonal prism has been developed. Now I am getting a rectangular prism in this particular case, which is going to form a guideline for developing this hexagonal prism construction as it is standing upright over there. Now let me draw it. These are the points A1, B1, C1 and D1. So these points they are corresponding to A, B, C and D points which were lying onto the base. Now we have worked out the center point for the base. Same way we are going to work out the center point for the top face also. So A1 to E1, the first center line will be drawn. B1 to F1, the second center line will be drawn over there. Now we have drawn the top rectangular face and we have also completed the bottom rectangular face for this hexagonal prism. Now we have to mark all the 6 points of the hexagon at the base, and all the 6 points of the hexagon they will be marked at the top face over there. Now step 1, we have marked the axis, and then these are the 2 points, that is A1, B2. So we have measured the distance A to 1 and B to 2, and then once you measure this distance on the true scale, convert it to the isometric scale, so we can mark the points A1 and B2 along this edge AB of the rectangle. Similarly, on the top face, same distances we are going to mark, that is A1, 1, 1, this distance. Similarly, B1, 2, 1 distance will be marked over there on the edge A1, B1 corresponding to the top face of this rectangle. Then next point is point 3. So the location of point 3 is at a distance of this much. Please see, we are going to measure the distance equal to B3, right, in the geometric figure. So once we measure this distance B3 converted to the isometric length, so we are going to mark this distance over here along BC. Similarly, B1, 3, 1 point has also been evaluated and it has been marked along the edge B1, C1. Then next we are going to mark couple of edges 4 and 5. So edge 4 and 5, once again the distances will be the same. So distance of 4 to C, 5 to D, A to 1 and 2 to B, they are all the same. So we are going to mark these points C to 4 and D to 5 along this edge CD. These 2 points they have been obtained. Similarly, along this edge C1, D1, so we are going to obtain C1, 4, 1 distance and D1, 5, 1 distance along this edge C1, D1. And finally this point 6 will be evaluated. We have to measure the distance of A6. So once we measure the distance of A6, we are going to mark the isometric length A6 on the base, and similarly A1, XIII will be marked on the top face. So all the 6 points of the hexagon, they have been plotted using rectilinear distances on the top face. All the 6 points of the base, they have been located using rectilinear distances on the bottom face. Now we are going to see which of these edges they will be dark, which of these edges they will be drawn by using construction lines, as they are not visible to the observer. Now the observer is going to look at this particular hexagonal prism from this direction. So this is the direction of the observer. Now the top face will be visible to the observer and under all situations. So please check: 1 1 2 1 3 1 4 1 5 1 6 1 and 1 1. So this hexagonal shape has been joined. Now corresponding to the vertical edges, we can see 1 1 and 1, it is visible, it is lying in the front side. 2 1 and 2, this is also visible, it's lying in the front. 3 1 and 3, it is also visible, and 4 1 and 4, this is also visible. But 5 1 and 5, this vertical edge is not visible, and similarly 6 1 and 6, these two vertical edges, they are also not visible. So they will be drawn by using construction line. Now regarding the base edges, we can see edge 1 2 is visible, that's why it's drawn dark. 2 3 is visible, that's why it has been drawn dark. 3 4 is also visible, so again drawn dark. But the base edges 4 5 5 6 and 6 1, they are lying behind this face over there, rectangular face, this rectangular face and this rectangular face. So these three rectangular faces, rectangular face 1, rectangular face 2 and rectangular face 3. So these rectangular faces, they are going to overshadow or cover the base edges 4 to 5, 5 to 6 and 6 to 1. Similarly, the vertical edges 5 1 5 and 6 1 6, they are also being overshadowed by these three vertical faces of this particular hexagonal prism. So this is the construction of the hexagonal prism, and this is the comparison you can see. So this is the first case when the two edges, they were perpendicular to VP. So this was the shape we had obtained. This is the second case we have just completed now, when the two edges of this prism, they are parallel to the vertical plane. So in both of these cases, we can see three base edges, they have been obtained to be lighter one, and two vertical edges, they were not visible. Over here also situation is almost the similar, but the construction shape has changed because of the change in the orientation. So here two edges were perpendicular to VP, here two edges, they happen to be parallel to VP. So we have discussed two cases of hexagonal prism when the prism is resting on the ground on its hexagonal base and the axis happens to be perpendicular to the horizontal plane, and in one case two edges, they were perpendicular to VP, in the other case two edges, they were parallel to VP. Now we are going to move on to the third case, that is we are required to draw the isometric projections of a hexagonal prism. Base is 20 millimeter and axis length, it is equal to 50 millimeter, as it is resting on one of its rectangular faces onto the ground. So this is the front view, this is the top view, and this is the side view. So please check, first of all we will be drawing a geometric figure of the hexagon having the edge is equal to 20 millimeter. So this is going to be our hexagon, and then we will be inscribing this into the rectangle, and this will be the longer edge AB. AB will longer edge has been given the name X, and BC, the shorter edge, has been given the name Y, and this is the length. So from the side view we'll be able to see 50 millimeter over here, whereas this 50 millimeter will also be visible in the top view. So please check, this is the top view. So in the front face, the labels we are going to use as A, B, C, D for the rectangle, and at the back face it will be A1, B1, C1, D1, and the 6 points of the hexagon in the front face, they will be located as 1 2 3 4 5 6, whereas in the top face you will have 1 1, 2 1, 3 1, 4 1, 5 1, 6 1. Now let us start with the construction of this isometric projections of the hexagonal prism. Now as usual, step number 1, the geometric construction of this hexagon will be completed. So this is the geometric construction of this hexagon, and once we complete this, points 1 2 3 4 5 6 will be marked over there. Then the diagonals will be joined and the center point or the axis point of this hexagon will be located, and finally we are going to inscribe this hexagon figure into a rectangular shape, so that this rectangular shape, because it is having all the edges which are lying on the isometric line, so that is why this will become our guiding figure. In the hexagon, these four edges, they are not lying on the isometric line, that is 2 3, 3 4, 5 6 and 6 1. So we cannot draw these edges onto the isometric projection straight away. So all the distances, that is x, y, distance of E, distance of F, distance of A1, B2 and B3. So all these distances, they will be first of all marked onto the true length, they will be converted onto the isometric length, and only then the projections they will be starting. Now in this case, this particular hexagonal prism is resting onto one of its rectangular faces onto the ground. So this point 1 2, it will be lying onto the ground over there, and then this length of 50 millimeter will be shown along this particular direction. So what we are going to do, step 1, we have drawn a horizontal locus line or a ground line and marked a point over there, and from this point towards the left, an x-axis has been drawn at an angle of 30 degrees. Similarly, the z-axis has been drawn at an angle of 30 degrees, right? So these are the isometric axes, and the height of this particular face of the hexagonal prism, so the height of this face, which is equal to y. So y is my height of the hexagonal prism face over there. This is the face of the hexagonal prism, which has to be drawn, please check, between this x-axis and the y-axis, because this will show me the shape of the face of this prism. So let me draw the y-axis. Please check, this y-axis is equal to the distance BC. This is the distance BC of the rectangle, and I have marked it as distance y. So please check, this is my distance y. Now how much is this distance that I need to draw onto the x-axis? It is my distance AB. This is my distance A and B, which is distance is equal to x. Now please check, this is the distance x I have marked along the x-axis. Now I am going to complete this rectangle over here. So these are the two isometric lengths which I have drawn, isometric lines I have drawn. So this edge is parallel to y-axis, and the height of this edge is also equal to y. Similarly, this isometric length is equal to AB distance over there. So this is parallel to the x-axis. So the one face, that is the front face of the hexagonal prism, has been drawn, and we will find that because this is the longer edge, so 2 points 1 and 2. So point 1 will lie here, point 2 will lie here. So my hexagonal prism will be resting on its base on one of its rectangular edges surfaces over there. Now I have to draw the depth also. So this length is given to me as how much? 50 millimeter. So the length of the axis is given to me as 50 millimeter. So this I have marked. So this is again drawn parallel to the z-axis. So my z-axis will show the length of the prism. So the front rectangular surface has been completed. Now I will be drawing isometric lines in order to draw a rectangular back surface of this particular prism. So let me complete it. This is again isometric line. This is again isometric line. This isometric line, it is parallel to z-axis. This isometric line, it is parallel to x-axis. Now this one I need to complete, the back surface. So the back surface is this. So once I draw this isometric line parallel to y-axis, this isometric line will be parallel to z-axis and this will be parallel to x-axis. So please check, this is AB, this length is also AB, this length is also AB, this length is also AB. This length, it is BC or Y, this length is also BC or Y, this length is also BC or Y, this length is also BC or Y. Similarly, this is the axis length 50, so this is also 50, this is also 50 and this is also 50. So what is this figure? This is a rectangular prism. So within this rectangular prism, this is the front face, this is the back face. Now on the front face, the 6 points of the hexagon will be located, and at the back face once again the 6 points of the hexagonal face will be located, and then the corresponding edges will be joined depending upon whether they are visible to the observer or they are not visible to the observer. So this is my back face, A1, B1, C1, D1. This is front face, A, B, C, D. Now let me find the center point. So from A to E, measure this distance, find the center line. From B to F, measure the distance, mark it over here and get the second center line. Now similarly at the back, A1 to E1, measure this distance, find the first center line. Similarly from B1, measure this distance, B1 F1, mark this horizontal center line. So this is axis point in the front face, this is axis point in the back face. Now the center points have been located, faces have been drawn. So only thing left is we have to evaluate location of these 6 points in the front face as well as in the back face. So let us start working upon that. All the 6 points we have located. So we know by now how to work out all these distances. A to 1, B to 2, C to 4, D to 5. So this distance remains same. A1, B2, C4, D5. Only one length you measure, 4 points straight away they will be available over here. Similarly, B3, it is equal to A6. So you measure this distance A6 and B3, mark 3 point from B and mark 6 number point from A. Similarly, the back points, they have been drawn. A11, 21, 31, 41, 51 and 61. Now all the 6 points of the hexagonal prism at the back face have been evaluated. All the 6 points of the hexagonal prism at the front face, they have been evaluated. Now the observer is going to look at this prism from this side. So all the edges of the front face will be visible. So 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 1. They will all be joined dark. Step number 1. Step number 2, this top surface is visible. So this has been joined dark. Similarly, 3 and 3, 1, this is visible. It will be joined dark. 4, 1 and 3, 1, this is visible. This will be joined dark. 2 and 2, 1, this is visible. This will be joined dark. 2, 1 and 3, 1, this is visible. This will also be joined dark. Rest everything will be light. So please check. 3, 1, 4, 1, dark. 3, 3, 1, again dark. 2 and 2, 1, this will be drawn, again dark, and 2, 1 and 3, 1 will be dark. And what are the remaining edges? Please check. 1 and 1, 1. So this is not visible. So this will be drawn light. 6 and 6, 1. It is again not visible. This will be drawn light. 5, 1 and 6, 1. It is not visible to the observer. This will be drawn light. And 1, 1 and 6, 1 and 2, 1 and 1, 1. So please see, on the back face only 3 edges are visible. 3 have been drawn light. In the front face all edges are visible.
So regarding the longer edges, 1, 2, 3 and 4. So 4 longer edges they are visible, but 2 longer edges, 1 and 1 1 and 6 and 6 1. So they are not visible. So this way we have discussed about the construction of the hexagonal prism, which happens to be resting on one of its rectangular faces onto the ground. Now you see, by joining this line light, I am able to make sure that this hexagonal prism is resting on its base on a rectangular edge. So what is this rectangular edge? 1, 2, 2, 1 and 1 1. So this is the rectangular edge on which it is resting onto the horizontal plane, right? So this is all for today, and we'll be continuing with few more cases on the isometric projections in the coming lectures. So thank you very much. Thanks a lot.